1. Introduction. What is this book about? Overview of the book's purpose, target audience, and scope. Brief history of design patterns, historical background on the development and evolution of design patterns. Should I take this book? Guidance on whether the book is suitable for the reader's needs and goals. Is it useful for interviews? Discussion on the relevance and utility of the book for interview preparation. How to use this book. Instructions and suggestions on how to effectively navigate and utilize the book's content. Organization of chapters. Overview of the structure and sequence of chapters in the book. Source code disclaimer. Disclaimer regarding the usage and reliability of any accompanying source code provided in the book. Tools used for book. Information on the software tools or environments referenced or utilized throughout the book. 2. UML basics. What is UML? Introduction to Unified Modeling Language, UML, and its significance in software engineering. Why UML? Explanation of the benefits and reasons for using UML in software design and development. UML notations. Overview of the various graphical notations and symbols used in UML diagrams. Object-oriented concepts. Review of fundamental object-oriented concepts such as classes, objects, inheritance, and polymorphism. OO analysis and design. OAD Introduction to Object-Oriented Analysis and Design Methodologies and Principles. UML building blocks and notations. Detailed explanation of the basic building blocks and graphical elements used in UML diagrams. Things. Explanation of UML. Things, such as classes, objects, interfaces, packages, and components. Relationships. Overview of different types of relationships in UML, including associations, generalizations, dependencies, and realizations. UML diagrams. Introduction to various types of UML diagrams, including class diagrams, sequence diagrams, use case diagrams, and activity diagrams. 3. Design patterns introduction. What are design patterns? Definition and concept of design patterns in software engineering. Brief history of design patterns, historical background on the emergence and evolution of design patterns. Why design patterns? Discussion on the advantages and benefits of using design patterns in software development. Categories of design patterns. Overview of the different types of design patterns, including creational, structural, and behavioral patterns. What to observe for a design pattern. Key considerations and characteristics to identify when recognizing design patterns. Using patterns to gain experience. Strategies and techniques for gaining proficiency and experience in applying design patterns. Can we use design patterns always? Exploration of the limitations and constraints of design patterns and scenarios where they may not be applicable. Design patterns versus frameworks. Comparison between design patterns and software frameworks, highlighting their roles and distinctions. 4. Creational patterns. Creational design patterns. Introduction to creational design patterns, which deal with object creation mechanisms. Categories of creational design patterns. Classification and overview of different types of creational design patterns, including factory method, abstract factory, builder, singleton, and prototype patterns. Factory method design pattern. Explanation and examples of the factory method design pattern, which defines an interface for creating objects but allows subclasses to alter the type of objects that will be created. Abstract factory design pattern. Description and use cases of the abstract factory design pattern, which provides an interface for creating families of related or dependent objects without specifying their concrete classes. Builder design pattern. Overview and implementation examples of the builder design pattern, which separates the construction of a complex object from its representation, allowing the same construction process to create different representations. Singleton design pattern. Introduction and scenarios for using the singleton design pattern, which ensures that a class has only one instance and provides a global point of access to that instance. Prototype design pattern. Explanation and implementation of the prototype design pattern, which creates new objects by copying an existing object, avoiding the need for subclassing. 5. Structural patterns. Structural design patterns. Introduction to structural design patterns, which focus on object composition and class or object structure. Categories of structural design patterns. overview of different types of structural design patterns, including adapter, bridge, composite, decorator, facade, proxy, and flyweight patterns. Adapter design pattern. Explanation and implementation examples of the adapter design pattern, which allows incompatible interfaces to work together by wrapping one interface around another. Bridge design pattern. Description and use cases of the bridge design pattern, which separates an object's abstraction from its implementation, allowing both to vary independently. Composite design pattern. Overview and examples of the composite design pattern, which treats individual objects and compositions of objects uniformly, enabling clients to manipulate them interchangeably. Decorator design pattern. Introduction and use cases of the decorator design pattern, which attaches additional responsibilities to objects dynamically, providing a flexible alternative to subclassing for extending functionality. Facade design pattern. Explanation and implementation examples of the facade design pattern, which provides a unified interface to a set of interfaces in a subsystem, simplifying their usage for clients. Proxy design pattern. Description and use cases of the proxy design pattern, which provides a surrogate or placeholder for another object to control access to it, adding extra functionality such as lazy initialization or access control. Flyweight pattern. Overview and examples of the flyweight pattern, which minimizes memory usage by sharing common parts of state between multiple objects, especially when the objects are largely similar but can vary in some aspects. 6. Behavioral patterns. Behavioral design patterns. Introduction to behavioral design patterns, which focus on communication and collaboration between objects. Categories of behavioral design patterns. Overview of different types of behavioral design patterns, including chain of responsibility, command, interpreter, iterator, mediator, memento, observer, state, strategy, template method, and visitor patterns. Chain of responsibility design pattern. Explanation and implementation examples of the chain of responsibility design pattern, which allows multiple objects to handle a request without explicitly specifying the receiver. Command design pattern. Description and use cases of the command design pattern, which encapsulates a request as an object, allowing parameterization of clients with queues, requests, and operations. Interpreter design pattern. Overview and examples of the interpreter design pattern, which defines a grammar for a language and provides an interpreter to interpret sentences in the language. Iterator design pattern. Introduction and use cases of the iterator design pattern, which provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Mediator design pattern. Explanation and implementation examples of the mediator design pattern, which defines an object that encapsulates how a set of objects interact, promoting loose coupling between them. Memento design pattern. Description and use cases of the memento design pattern, which captures and externalizes an object's internal state without violating encapsulation, allowing it to be restored to a previous state. Observer design pattern. Overview and examples of the observer design pattern, which defines a one-to-many dependency between objects, ensuring that when one object changes state, all its dependents are notified and updated automatically. State design pattern. Introduction and use cases of the state design pattern, which allows an object to alter its behavior when its internal state changes, encapsulating state-specific behavior into separate objects. Strategy design pattern. Explanation and implementation examples of the strategy design pattern, which defines a family of algorithms, encapsulates each one, and makes them interchangeable, allowing clients to vary algorithms dynamically. Template method design pattern. Description and use cases of the template method design pattern, which defines the skeleton of an algorithm in a method, allowing subclasses to override certain steps of the algorithm without changing its structure. Visitor design pattern. Overview and examples of the visitor design pattern, which represents an operation to be performed on elements of an object structure, allowing new operations to be added without modifying the objects themselves. 7. Glossary and tips. 7.1 What are design patterns? Definition and explanation of design patterns in the context of software development. 7.2 How to use design patterns? Guidance and best practices on effectively applying design patterns in real-world projects. 7.3 Why design patterns? Discussion on the benefits and advantages of using design patterns in software design and architecture. 7.4 What to observe for a design pattern? Key factors and considerations for recognizing and applying design patterns in different scenarios. 7.5 Using patterns to gain experience. Strategies and techniques for gaining proficiency and experience in utilizing design patterns. 7.6 How to choose a design pattern? Guidelines and criteria for selecting the appropriate design pattern for a given problem or requirement. 7.7 Can we use design patterns always? Exploration of the limitations and constraints of design patterns and scenarios where they may not be suitable. 7.8 Categories of design patterns. Overview and classification of different types of design patterns, including creational, structural, and behavioral patterns. 7.9 Creational design patterns. Explanation and examples of design patterns focused on object creation mechanisms. 7.10 Structural design patterns. Description and use cases of design patterns concerned with object composition and class or object structure. 7.11 Behavioral design patterns. Overview and examples of design patterns emphasizing communication and collaboration between objects. 7.12 What are anti-patterns? Definition and examples of common design pitfalls or anti-patterns that should be avoided. 7.13 Refactoring. Introduction to refactoring techniques for improving the design of existing code bases while preserving functionality. 7.14 Design patterns versus frameworks. Comparison between design patterns and software frameworks, highlighting their respective roles and characteristics. 7.15 Tips. Practical tips and advice for applying design patterns effectively and efficiently in software development projects. 8. Design interview questions. 8.1 Design interview questions. Compilation of commonly asked design interview questions and scenarios. 8.2 Sample design questions for practice. Practice exercises and sample questions to help prepare for design interviews, along with suggested solutions and approaches. These sections provide a comprehensive understanding of design patterns, their application, and preparation for design-focused interviews.